today we're going to be learning about differentiation. So to start off with, what is differentiation? Well, the official definition is the rate of change of a function. But it's basically a way of measuring how quickly something changes when compared to something else. So why do we even care about this? Well, differentiation is one of the most powerful tools for understanding and measuring the world. It can be used to measure the movement of planets. You could use it to predict where a skydiver is going to land after they jump out of a plane. You could use it to predict how quickly some mold will grow in a bit of bread. Just about anything that changes can be measured through differentiation. So I'll try to go through and explain the concept through with kind of build it up from some simpler ideas to getting on to the more complex ideas. So the classic example of differentiation, how fast was I going? So, if you're riding along on your motorbike, what's it called again? Quad bike, and you don't want to get caught out for speeding. How do we even know how fast you're traveling at that point? Well, the answer is differentiation. And the specific example of speed is when think about it. You know how speed is measured in miles per hour. That's how fast we know we're going. So you can think about that as you're measuring the change in distance with time. And another way of saying this would be you're differentiating the distance with respect to time. So you're looking at how the distance you're traveling changes with time, and that gives you your speed, and that basically is differentiation in its kind of most simplest form. This is like the classic example of distance speed. We'll go into that in more detail later in the course, but just for now to try and show you that point, when we differentiate distance with respect to time, we get velocity, and when we differentiate velocity with respect to time, we get acceleration. Again, we'll go into this in more detail later, but just to try and illustrate the point of what's going on. So you've got distance, that's measured in meters. Then you have velocity, that's measured in meters per second. And then you have acceleration, which is measured in meters per second squared, or meters per second per second. So the point I'm just trying to make here is you're looking at a physical property, and this time it's distance, and then you're looking at how it changes with time, so that's seconds, and then you can take that to the next level. But that I hope that gives you kind of a base understanding of what's going on here. Right, thank you very much. Moving on.